Example 5, we're doing a bit of an application. We have a cylinder's volume. So just to review, a cylinder, at least cylinder, you can have really any shape at the ends, and then they're connected with straight lines, but usually we have circles at either end. So this is what a cylinder looks like. And we have this volume polynomial, and cubic units are just for volume. And then it says the base area is given by this many square units. So we need to figure out how to do the volume. So the volume of a circular cylinder is pi r squared h. But what this pi r squared is the area of a circle, the area of the base. So the other way to look at this formula is that it's the area of the base times the height. And that's what they want us to use for this one. All right, so volume, this whole thing is V. So let's put it here. 36 pi x to the 6th plus 27 pi x cubed plus 24 pi x squared. So that's the volume, and it equals the area of the base, which is 9 pi x squared. They tell us that. Times this height we don't know. And I'm going to leave it as a word because this is what we're trying to find. It says find the cylinder's height. So what I need to do to both sides then is divide by 9 pi x squared. Divide by 9 pi x squared. So that those cancel. And then this is what we were doing in the previous examples, which is we're going to separate it into 3 separate fractions to divide a polynomial divided by a monomial. All right, so let's write it out. We got 36 pi x to the 6th over 9 pi x squared plus 27 pi x cubed divided by 9 pi x squared plus 24 pi x squared divided by 9 pi x squared. And we're just going to simplify each of these fractions independently. So the first one, 36 divided by 9, that's 4. Just mark down what I'm doing. So I divide the numbers, get 4. The pi's cancel. And then what's left, if we have 6 x's on the top and 2 on the bottom, what's left is x to the 4th. So it's 4x to the 4th. There we go. Next fraction, same thing. 27 divided by 9, that's just 3. So we still have that plus sign, plus 3. The pi's cancel. And then x cubed divided by x squared is just x. There'll be one x left on top. Last one, 24 divided by 9. Well, that doesn't divide evenly, but no big deal. We just need to simplify or reduce this fraction. So we got to think about, well, what can we divide both 24 and 9 by? And the only thing that multiplies the 9 is 3 times 3. So let's try 3. Divide by 3, and we get 8/3. So 8/3 is just going to be in our answer. It's fine to have fractions. Just like the other ones, the pi's cancel. And in this one, the x squareds cancel, so there isn't any x left. When everything cancels, the only thing left behind is a 1, right? The x means that there was 1 x extra on top. So this formula is the height of the cylinder. Because all we did was take the volume and divide by the area of the base that they gave us. All right, a little complicated. Let's start this next section, which is multiplying polynomials. So this was dividing polynomials, right? Or at least dividing a polynomial divided by a monomial. Now we're going to multiply a polynomial times another polynomial. But let's start with a monomial, which just means we have one term. And then in the next video, we'll talk about, well, what happens if we have more than just one term. But starting with one term, all this really is the distributive property, which means, like in example 1, we're going to take this 2x and multiply it by both pieces in the parentheses, both terms. So if you want to write it out, you can, but I'm hoping we can just multiply this. So 2 times 3 is 6, and x times x makes x squared. The plus sign stays plus. 2 times 5 makes 10, and then there's just the single x. So all we're doing is the distributive property. The difference is really there's just more variables than like in an Algebra 1 class when we learn distribution. So let's try this. We definitely got more variables now. We got to use the rules of exponents, but we can handle that. So we're distributing, and we got to be careful with our negative sign. So -3 times +2 is -6, and then t cubed times t to the 5th, that makes 8 t's. We're going to add the exponents when we multiply. Let's do a quick review of the rules of exponents. So if we're multiplying t cubed times t to the 5th, that's when we'd get t to the 3 plus 5, or t to the 8th. If we had t cubed to the 5th power, that's when you end up multiplying the exponents. So those are the two that are easy to mix up. So we just got to keep reminding ourselves which one we're doing. So in this case, we're adding exponents. And now -3 times +1 is -3, and then t cubed is still there. All right, hopefully those make sense. Let's try this last one in this example. This time, there's 3 terms in the parentheses, so that means there's going to be 3 multiplications. There's nothing to multiply the 4 with. Y squared times y squared, we're going to add exponents, so it's going to be 4y to the 4th. Then 4 times -11 is -44. And if it helps, definitely put a little 1 when there's a variable with no exponent on there, because this together makes y cubed. We have y squared and y to the 1st, so that's y cubed. And then last term, +4 times -5 is -20 y squared. All right, hopefully that makes sense. So if you want, try these on your own, pause the video, and then you can check yourself. So it's the same thing, we're just distributing. So -5 times +4 is -20, and then t times t makes t squared. -5 times -1 is +5, and then the t is still there. All right. Part B, we have 3 different multiplications. 4 times 2 is 8. X cubed times x squared. If we add those exponents, it makes x to the 5th. 4 times -3 is -12. There's another one where it might help to put a little 1 on the exponent to remind ourselves that x cubed times x makes x to the 4th, because we add those exponents still. And then plus 24x cubed.